Hello. One more recording to conclude chapter 12. Let me bring up chapter 12 real quick right now. Okay, so now we've learned about aldehydes and ketones. The first reaction we learned about was oxidation. Now let's do the opposite, reduction. So reduction can be in the form of loss of oxygen or the addition of hydrogen, like we see here. Now, this reaction is very similar to the hydrogenation of alkenes. So just as a refresher, um, if you look at your green sheet at the list of reactions, if you look at the hydrogenation of alkenes, there is a double bond between two carbons. It reacts with hydrogen. That double bond breaks open, and each of those carbons now has a single bond between them, and each of those carbons gains a hydrogen. We see a very similar reaction here with the reduction of the reduction of aldehydes and ketones. So instead of a carbon-carbon double bond, though, we're dealing with a carbon-oxygen double bond. So the carbon oxygen double bond, so if we go all the way down here, we see this carbonyl, okay? The hydrogen will break open. We see the same heavy metal catalyst required to break that hydrogen-hydrogen bond. The carbon-oxygen double bond will break open. One hydrogen bonds to the carbon, one hydrogen bonds to the oxygen, forming the resulting functional group, which is an alcohol. So we get instead the carbon has an additional hydrogen, and then the oxygen becomes an alcohol. We will, in our class, always see this in the form of an aldehyde or ketone plus hydrogen. Your book also has the NaBH4 reactant. If you see that in the book, just consider it H2. It behaves the same as H2. So I will always have it as H2. So what this produces is an alcohol. Now, in the case of an aldehyde, where the aldehyde must always be on carbon 1, what results is always a primary carbon. Hey, let's refresh ourselves on categorizing alcohols. So whenever you're categorizing an alcohol, look at the carbon the alcohol is coming off of and count how many other carbons it's bonded to. This carbon is bonded to one other carbon, so this is a primary alcohol as indicated in the figure. Okay, let's look at the reduction of a ketone. Same reaction, it's just happening in the middle of the molecule instead of on the end of the molecule. Oh, I have a sneeze that's just going to come out in the middle of this, and it's going to be awful and hilarious. I can just feel it coming. Okay, so we've got the ketone in the middle of our propanone. That double bond will open up. Each of the hydrogens will bond to one of the one of the atoms involved in the double bond. So one hydrogen will go to the carbon, the other will go to the oxygen, forming our alcohol. What results is an alcohol, and when we categorize that alcohol, we look at oh, why is my computer? Hang on just a second. Here we go. We look at the carbon bonded to the alcohol and we count how many other carbons are involved. Not involved, excuse me, I just got distracted. We look at how many other carbons are bonded to that carbon. 1, 2. So this is a secondary alcohol. So ketones produce secondary alcohols. Because we are always adding a hydrogen to that alcohol carbon, we can never produce a tertiary alcohol. Always a primary alcohol coming from an aldehyde and a secondary alcohol coming from a ketone because of the location of the carbonyl. So I have two problems right here. The second one didn't copy all the bonds. So let's just draw in these bonds. Bond, bond, bond. Okay, we've got an aldehyde here with a double bond O and a single bond H. So if we were in class right now, I would give you some time to practice this. I'm going to give you some time to wipe my nose right now. And then we're going to, in the first one, I gave this to you to practice. Just consider that an H2. There's a typo here. This H2 should be in front of the arrow. So I invite you to try pause this and to practice it, but I'm just going to move on. Our double bond to O is going to break open. That O will gain an H. The carbon will also gain an H, but because it's a line angle drawing, we don't draw that H bonded to the carbon. So we just see the double bond O turn into an OH. And then any other substituents, those are going to remain the same. So we have a methyl group on our second carbon right here. That remains a methyl group. Nothing changes about that. Only the ketone part changes into an alcohol. All right, let's look at our next one. So this is the only part of the molecule that will be affected. The rest of the molecule will stay the same. And this is a characteristic of all organic reactions. We look for the functional group. That's the part that changes. The rest of the molecule remains the same. So we're going to see, I'm going to change around that H3C to a CH3, same thing. So this part of the molecule remains the same. Now this carbon, didn't leave much room for myself, that double bond O becomes an OH, and this carbon already had one H, it's going to gain a second H. So that's going to be a CH2. If you draw those two H's separate from each other, that's fine. Excuse me. I'm going to go bathe in hand sanitizer after this. We just see that the alcohol is on that first carbon. If you were to draw this molecule in line angle, which I know a number of you have preferred that, why don't we do that? 1, 2, 3, 4, 5. The OH comes off of that first carbon. If you have an OH coming off of the end of a molecule, it does get its own little line. The Br remains off of that third carbon. So this is what it would look like. And that finishes off chapter 12 for us. And that is what we covered in lab in the Tuesday lab. All right, I'm going to go get some rest. I hope you all have a good weekend, and I will see you next week on Tuesday.